Hello everyone. We're going to continue our conversation and our discovery of looking at systems. And we're now going to look at systems of inequalities. And in this first video, all of our equations or all of our inequalities are going to be in the slope-intercept form. The second video, we'll look at them in standard form. So our learning target, we want to be able to represent and solve those system of inequalities. And we know that we're going to be successful when we can graph those linear inequalities, which are in two variables. And then after graphing them, we're going to be able to look at our answer, and we're going to be able to determine what our solution to the actual system of inequality is going to be, and we'll be able to justify that. So let's get started. So they want us to sketch the solution. So when it comes to your guys' homework on this, you guys need to be as precise as possible. I get that you might be off by a quarter or possibly a half, but you should not be any more than that. You guys, I made the graphs big enough on the worksheet for you guys to use, or you can do it on graph paper. Use a straight edge if you need to be, but these do need to be as accurate as possible, okay? So I'm going to try that on this iPad of mine with no straight edge, so bear with me. All right, so let's start off with our very first equation, or sorry, inequality. So like I said, these ones are all in slope-intercept form. We can recall slope-intercept form is that y equals mx plus b form, where b is our y-intercept, which is where we're going to cross the y-axis, and m is our slope, so that's that change in y over change in x. So once we graph our intercept, we can figure out our change in y and change in x, and we can actually have any 2 points, and then we can at least graph the line and then move on for our inequality from there. So let's start off with our first inequality. So we got y is less than or equal to negative 1/2 x minus 2. So if I want to graph that, I know that I'm going to cross the y-axis at negative 2. So my first point is going to be at negative 2. My slope for this one is negative 1/2. So I can either go up 1 into the left 2, or I could go down 1 into the right 2, right? So I have my 2 points, so now I can graph my line, and I just need to be careful with my line. I need to go back up to my inequality, and I see that y is less than my negative 1/2 x minus 2. It can't equal it, so it's not part of the solution set. So since it's not part of the solution set, we don't draw it as a solid line. The solid line says that it can be a part of the solution. So anytime we don't have that equal sign underneath, we know it cannot be a part of the solution. So in order to denote that, we do it by making the dashed line, such as that, right? So now that we have our line drawn for our inequality, now we need to figure out where we need to shade this, because ultimately we know that the y values, because it can't be equal, we either have to be greater than this line, or they need to be less than this line. And our inequality, y is less than. A couple different ways you can do this. If you wanted to, you could arbitrarily pick any point on the coordinate plane and plug it in and see if it's true or false. For example, if I picked the point 0, 0 and I plugged it into here, I'd actually come up with that 0 is less than negative 2, and I know that is false. So this can't be shaded because that wouldn't be my solution set. The other way I look at it too is like y is less than. So I actually just kind of come right over here to where the y-axis is, and I cross right here, and my y values have to be less than that point right there. So where is y less than that? Below. So when it comes to shading this, I'm going to shade it below that line. So sometimes we work on our coloring technique, right? All right. So I think I'm okay with my first equation, or my first inequality. So now I'm going to look at the second inequality. Y is less than or equal to negative 5/2 x plus 2. So in order to graph it, it's in that slope-intercept form. I'm going to cross the y-intercept at a positive 2. So my first point is going to be at 0, 2. my slope is negative 5/2. So I can either go up 5 and to the left 2, but I'm off of the grid, which could possibly make it to where it's not as accurate as it needs to be. So I'm going to go down 5, 1, 2, 3, 4, 5, and to the right 2. And I'm gonna, now I have 2 points, so I have enough to make a line. And on this one, I have y is less than or equal to. So since it's equal to, that equal means that it can be a part of the solution set. So I'm going to draw this as a solid line. And this one's going to be a little tricky for me. There we are. So now my next part is to figure out my shading. So again, my y is less than negative 5/2 x plus 2. So I can either pick any point on the coordinate plane and see if it's true or false. So for example, if I put in the point 0, 0, I'd get 0 is less than or equal to 2. So that is true. So I know that that point is a true solution. So that's where it's going to be shaded. The other option is looking where it crosses the y-axis. Y has to be less than. So to be less, it's going to be below. So I know that this is going to be shaded below that line, which is going to be all of this, right? And that would be the solution to my second inequality. But ultimately, this is a system, right? And we remember that a system is where you have 2 or more equations or inequalities, and they have to be working together. So when it comes to finding the solution for this system, it's where they are both shaded at the same time. So when I look at here, where am I technically green and orange at the same time? That is going to be in this area through here, right? So this part is my actual final answer solution to that system of equations. All right, let's try another example. So again, when I look at my 2 inequalities, they are technically both in that y equals mx plus b form, so they are both in that slope-intercept form. So let's just start off with our first one. So y is less than or equal to negative 2x plus 1. So my y-intercept is going to be positive 1. And my slope is negative 2. So I either can go up 2 and to the left 1, right? Or I could go down 2 and to the right 1. On this one, I have 2 points, so I can graph. I need to see if it's going to be a solid line where it's part of the solution or not part of the solution. And it might be a little blurry for you guys, but there is a line underneath, so it is equal. So since it is equal, I am going to draw a solid line. All right, there we are. So now again, I'm going to check my points to see where I need to shade. So y has to be less than. So I'm just going to go over to, oops, sorry about that. I am just going to go over to where my line is. Y has got to be less, so I know that that's got to be below. So I am going to shade below. So sometimes when you do these on your own, if you have colored pencils, some people do them in two different shades of colored pencils, or push harder on the second time than the first time sometimes helps. Another cool trick actually is to using highlighters. And if you use, I don't know my colors very well. If you use like a yellow and a orange highlighter, I believe it actually turns to a orange. Test me if I'm wrong. Let me know. Then I'll know if you watch the video or not. I believe it changes color, so then it's kind of easier to see because the highlighter kind of does the work for you. So highlighters are cool for that. All right, back to some graphing. So now let's try our bottom one. So on our bottom one, y is less than 2x minus 3. So my y-intercept is negative 3. So 1, 2, 3. And then my slope is 2, so I could go up 2 and over 1, right? Or I could go down 2 and to the left 1. When I look at my original inequality, it does not equal, so I know that it is not part of the solution set. So I know it's going to be a dotted or a dashed line, right? And then in order to figure out where my shading is going to go, y has got to be less than. So I'm just going to go where it crosses the y-axis. It's got to be less than. So it is everything that is below this line. Right? Close enough for you guys? This is hard doing the videos. I can't crack jokes. There's nobody here to laugh at them. But then again, I guess it's no different than when I was in the classroom, right? You guys never laughed at my jokes. Some of you did. All right. So to figure out my solution to my inequalities, it would be where these inequalities are working together, where they're both true, and they're both going to be true in this little area down here, right? And that's my final solution. So you need to somehow make sure you're denoting that that is your final solution. For example, on mine, I made it a different color than the other two, shaded in a lot darker than what your other ones are, or like even with the highlighters where it'll show up as a different color. But I need to know for sure that you know which part is the only solution. All right. I'll get ready to get another video up there for you guys where on the next video, same concept, but instead of being in slope intercept form, they might be in standard form for us to graph. Talk to you soon. Bye.